I'm Patience, a developer from Vietnam, and this is Source History, where we don't just tell the past, we debug it. France spent nearly 60 years building Vietnam, then lost it in 56 days. As a developer, my first question isn't why. It's what was the technical debt? And more importantly, who was paying it? Let's start with the system design. The French colonial model looked functionally like a centralized monolith, not literally one server, but it behaved like one. For non-developers, imagine a single system handling everything. Database, logic, interface, all tightly coupled. That system? Paris. Tax policy, infrastructure, even rice prices in Saigon. Everything had to route through it. Response time? Months, sometimes a year. In software, that's a bottleneck. In history, they called it governance. But let's deep dive into this monolithic infrastructure. It wasn't just centralized, it was inherently inefficient. A classic case of code bloat and legacy hardware trying to run a modern application. Code bloat. Imagine a code base where every single rule, every tiny regulation, wasn't written locally, but imported directly from a remote server. That was the legal and administrative framework in colonial Vietnam. Laws, decrees, even minor adjustments to salt or alcohol prices had to be drafted in Paris, sent halfway across the world, and then approved. This created immense latency in governance. Any small change required a round trip that could take months, sometimes even a year. It was like trying to deploy a hotfix to a production server located on another planet. Legacy hardware. Adding to the complexity, the French didn't completely dismantle the existing hardware, the old imperial court system in Hue. Instead, they tried to run their new operating system on top of it. This was a classic wrapping an old API in a new container scenario, but with severe compatibility issues. The traditional Mandrinate, designed for a different era and purpose, was forced to execute French directives. The result? Constant system errors, misinterpretations, and a general lack of cohesion. It was a Frankenstein's monster of administration, prone to crashes and unexpected behaviors because the underlying components were never truly integrated. Now here's the problem with monoliths. They work until they don't. And when they fail all at once. Vietnam had been sending bug reports for decades. Famines, uprisings, resistance movements, each one a signal. The system is not working for the end user. And the response? Works on our machine. The machine being Paris. The users were not in Paris. At some point, end users stopped filing bug reports. They stopped waiting for the patch. They decided to ship their own version. This wasn't just a failure to respond. It was a massive accumulation of technical debt. The French system was designed for extraction, not for sustainable development. And this debt eventually came due. Resource leaks. Instead of reinvesting in the system, things like education, healthcare, infrastructure for the local users, the French colonial administration was primarily concerned with querying resources out of the system. Rubber, coal, rice. These were continuously extracted, creating massive resource leaks that starved the local economy and populace. It was like a server constantly running at 100% CPU, with all its output being siphoned off, leaving no capacity for internal processes or upgrades. Security vulnerabilities. This systematic oppression and exploitation created profound security vulnerabilities. The discontent among the indigenous population wasn't just a minor bug, it was a gaping exploit. Secret organizations, patriotic movements, these were the hackers who were constantly probing the system, looking for weaknesses, and eventually finding ways to infiltrate and dismantle it from within. The more the system ignored the bug reports from its users, the more severe these vulnerabilities became, leading to inevitable breaches. Let's look at a specific example of this system's failure: the rubber plantations. The rubber plantations were designed for maximum output, optimizing production at all costs. They were supposed to be highly available for French economic interests. However, the runtime environment for the workers, the living and working conditions, was abysmal. The crash rate, mortality rate, among laborers was so high that the system couldn't even self-heal or replenish its workforce naturally. It was a system pushed to its breaking point, where the pursuit of raw output completely disregarded the human cost, leading to catastrophic system failure on a human level. Before we get to Dien Bien Phu, it's crucial to understand that while the French were clinging to their failing monolith, a completely different operating system was being built in parallel. Decentralized network. While the French concentrated their power in centralized nodes like major cities, the Viet Minh adopted a peer-to-peer model. They operated in the rural areas and mountains, building a decentralized network of support and control. This distributed architecture made them incredibly resilient. If one node was compromised, the entire network wouldn't collapse. Unlike the French monolith. Offline first. The Viet Minh system was designed to be offline first. It could function even when connectivity was cut off, during sieges, blockades, or communication blackouts. They relied on protocols like word of mouth and human couriers. It was slow, yes, but it was robust. There was no single server to be taken down. This fault tolerance was a critical design choice that allowed them to persist and grow despite overwhelming odds. In 1954, that fork met the original system. At Dien Bien Phu, 56 days, that's all it took. In development terms, this was a merge conflict. Two versions of the same system trying to exist in the same place. One had to overwrite the other. There was no clean resolution. France accepted incoming changes. This wasn't just a battle, it was a brutal stress test between two fundamentally different system designs. The hedgehog concept. The French, confident in their monolithic approach, built a massive data center in the Dien Bien Phu Valley. They believed it had an impenetrable firewall of artillery and air support. It was a fortress designed to withstand any direct assault. A classic example of over-reliance on a single, heavily fortified point of failure. DDoS attack. The Viet Minh didn't launch a frontal assault on this firewall. Instead, they orchestrated a massive distributed denial of service attack. They used tens of thousands of requests, civilian laborers, manual artillery hauling, to encircle the French position, systematically cutting off their only bandwidth, the air supply. This wasn't about brute force. It was about resource exhaustion. When the bandwidth dropped to zero, the massive Dien Bien Phu monolith, starved of resources, simply timed out. It was a masterclass in exploiting the weaknesses of a centralized system with a distributed, persistent effort. Now here's where it gets interesting. While France ran a monolith, the British and Malaya used something closer to microservices. Distributed control, local autonomy, central coordination, different architecture, not better ethics. Same extraction, different system design. And when stress hit, like World War II, distributed systems handled it better. I'm not saying the British were good. They were running the same exploitation software, just with better system architecture. And from where I'm from, this wasn't just a system failure. It was lived experience. My grandparents' generation didn't read about this in a textbook. They were the end users. And nobody asked them if the system worked. This personal connection, this human-in-the-loop perspective, is what makes history truly resonate. It's not just about abstract systems. It's about the impact on real people. Here's what history and software engineering both teach us. Centralized systems feel powerful until real load hits. If everything depends on one node, failure becomes inevitable. France didn't just lose a war. It deployed a system that couldn't scale to the people it was supposed to serve. The world wants speed, but the system requires stability. Success isn't a sprint. It's a long-running process with a very high uptime. My name is Patience, and I'll see you in the next commit.